Okay, so let's start. Let's assume that we have this six stocks: Nvidia, Tesla, Walmart, Boeing, HP, and Ford Motors. And we have the stock prices for last 5 years, starting from 9/17, 2019 till 9/16, which is yesterday. Okay, that's the closing price for each of them. So the first thing that you need to do is just find out the returns for all of them. I'm just gonna copy paste the headers and do this thing. Natural log of today's price, which is 9/18/2019, divided by the previous day's price. So that's going to give me the return that it earned by going from 4.5 to 4.47, which is negative 0.0604 percentage. And you just copy paste that. So it's going to give you all the returns for the everyday for last 5 years. Now, of course, we need something here as well. So if I copy paste this here, so it's going to throw up an error saying that there's a value error, given that is trying to divide 4.5 divided by NVIDIA, which is a text value. So of course, it's going to throw up an error. So what we're going to do is we're just going to apply a wrapper around it called as if error. So if this log natural function throws me an error, then at that point, just call it 0 and press enter. And then we apply the same formula across everywhere and copy paste all of this. Okay. Okay, so once we have this, now we are ready to find out the return and the risk of each of these stocks. I'm just going to copy paste all of this here somewhere. And let me just hide this thing since we don't need it. Okay, so I'm going to find out the return. So if I do just an average of daily NVIDIA return, it is going to give me some value. And then you can copy paste all of that here. So it's an average daily return, but we can annualize that return by just multiply this number by 262. That's the easy way to find out the annual return of each of this stock. Similarly, we can find out the risk. And this is nothing but standard deviation of, it doesn't really matter if you do standard deviation P, which is population, sample, everything is same here. We are just going to find out the standard deviation of risk and copy paste all these values here. Now, one thing that you need to understand while annualizing the return is you have to multiply this number not by 262, but by square root of 262. So copy paste all of that here. So now you can create some kind of measure like return divided by risk or risk divided by return, whatever you want. So I'm just going to do return divided by risk and find out all the values here. Okay, so what it means is that for example, for NVIDIA, for every 1% of the risk that you take, you are getting 1.24% of return. But on the other hand, every 1% of the risk that you take for Boeing, you are getting a negative 0.35% of return. So that's something that you need to understand, that this is like a proxy of a Sharpe ratio, you can say. Okay, once we have that, next thing we need to find out is something called as the variance covariance matrix. Okay, so the way that you do that is you go to data. Let me do one more step before that. Let's find out weights here. Let's assume that we want to put some equal amount of weight in all the six stocks, right? So what I'm going to do is 1 divided by 6, which is 0.16 or 16% of weight in each of these stocks. If I do a summation of this, obviously it's going to be 1, but this is going to be important later on when we do use the solver function. Okay, now we can go and data analysis and go to covariance here to find out the covariance matrix. Okay, it's asking for input range, which is nothing but this starting from NVIDIA to Boeing and up till the end of the last date. And we can select the labels in the first row, given that the titles were in the first row. And I'm going to select the output range here, which is where I want my output to be. And I want my output to be, let's say, somewhere around here in the X column. Okay. And once I hit OK, it gives me this value. So it's a triangle. As you can see, it's a triangle like this. So what we need to do is copy these values right here, starting from Tesla to Boeing, and paste these values right here. Okay, so it's like a transpose function in matrix. So the way that you can do is just Control C, and I'm going to home, paste, and transpose. Oh, I'm sorry. Okay, let me try again. Copy, then select the cell Tesla right here, and now go and do the transpose. Okay, so copy this, and I'm gonna show you a shortcut. It's Alter H V, and then you press the button T to transpose it. Okay, so Control C, Alter H V T, Control C, Alter H V T, and Control C, and right here just Control V. Okay, so now we have this is called as the variance covariance matrix, and yeah, I'm just gonna give it a title. So variance covariance matrix. Okay, once we have that, I'm just gonna multiply this thing by 262, given that this is a daily variance covariance matrix, and we need an annualized version of this. So I'm just gonna do this value multiplied by 262. Oops, it's 262. And that's it. Okay, once we have the covariance matrix, now the part becomes really easy. Okay, okay. So return on a portfolio. That is easy, right? I mean, it's a sum product of all the weights, and array 2 is all our annualized return. Oh, okay. This needs to be adjusted here. Okay, so on this portfolio, if you had invested 16% in each Tesla, Nvidia, HP, Ford, and Walmart and Boeing, you would have earned 22.48% return annually over last 5 years. And similarly, we want to find out the risk of a portfolio. And the way that we do it is MMult, which is the matrix multiplication of your weight and your variance covariance matrix. And on the outside here, we do another matrix multiplication with this value and transpose of the weights. Okay, here this needs to be again. Yes. Okay, and here's the thing to remember. If you just press enter here, it's gonna throw an error saying it's a hashtag value. So what you need to do is actually press shift and enter. Okay, control shift and enter, not shift and enter, control shift and enter, and that's gonna give you the risk. So this is the risk, which is 10% here. Okay, not sure if it is a risk or a variance. Let me do square root of that. Okay, yeah, this is a variance of a portfolio, not the risk. So risk is nothing but square root of this value, which is 32%. Okay, by the way, risk is not actually a percentage measure. We should not be using that as a percentage. It's just a decimal. Okay, variance is in percentage, risk is not in percentage. Okay, now we can do a Sharpe ratio. Sharpe ratio is nothing but if you look at, let me check Google to show the formula. Okay. Okay, so as you can see, Sharpe ratio is nothing but the return on a portfolio. I don't know if you can see that because I'm not sharing the screen probably. Okay, let me just copy paste that thing. Okay, this is the Sharpe ratio, which is nothing but return on a portfolio minus the risk-free rate divided by the risk of portfolio. So we already have the return on a portfolio, as you can see right here. And we already also have the risk of a portfolio, which you can see right here. Okay.
શું ચૂતિયો માણસ છે ઘોસડીનો શું ચૂતિયો માણસ છે
Cool, sir.
હા અમારો આ ત્રીજી વખત એવું કર્યું કે એને ક્લાસ
Okay, sorry about that. Looks like my roommate Hemil was a little bit frustrated right now. Okay, let me see if the screen sharing is on. Okay, screen sharing is on now. Okay, so as we discussed that the Sharpe ratio is nothing but the portfolio return, which we already have here, 22.48%, and portfolio risk is 0.3215, and all we need is the risk-free rate, right? So for just simplicity, let's assume that the risk-free rate is 2%. So in the last 5 years, if you remember, after the COVID happened in across the globe, every government actually cut down the interest rate, and the risk-free rate in US were near zero at that point in time. But for our purposes, we are just going to assume that is about 2%, which is historical long run average risk-free rate in the United States. So what we're going to do is nothing but this thing right here, return on the portfolio minus risk-free rate, and then we're going to divide by risk here. So that's going to give me a Sharpe ratio of 0.64. Okay. Now this is important measure for us to understand. Our goal from a modern portfolio theory is to minimize the risk and maximize the return, right? So the way that we do it by changing the weights here. So if I want to change the weight from 0.16 to 0.2 here and reduce Boeing from 0.16 to something else, it's going to give me a different return. And based on the risk and return values that we are going to get out of this, we can create an efficient frontier out of it. But at this point, our goal is to maximize the Sharpe ratio. So what I'm going to do is go to data and go to solver. I hope it's solver. Yeah, solver. And I want to select this cell here, right here, and I want to maximize the value of that by changing what? By changing the weights, of course, right? So by changing the cells, P to U, and subset constraint, this needs to be equal to 1. This summation of the all weights needs to be equal to 1. And I'm going to add that. Okay. And also one more constraint that none of these values needs to be less than 0. So we can make this as greater than or equal to 0 because we don't want to do a short selling in this case. And everything seems fine. So click on solve. And when you solve that, these numbers are going to get changed here. Okay. So initially everything was 16%. Let me just click OK here. So everything was 16.66%. Now the new weights are saying that you should not be investing in HP, Ford, or Boeing at this point in time, or you should not have invested in last 5 years. Let me clarify that. And you should have invested 48% in Nvidia, 9% in Tesla, and 41% in Walmart. So even though Tesla is something that we all think that, okay, Elon Musk, and yeah, it's a good stock, it gives good returns, but the amount of risk is also huge in the stock, right? As compared to that, if you have invested in Walmart, you could have probably minimized your risk and maximized your return. That's what I was trying to say here, right? So yeah, that's about it on how to optimize the portfolios. Okay, thank you.